Hi guys, welcome back on the Malachite tutorial part 3.2. We're gonna talk about scale attributes for the scattering of a crystal. Let's dive in. So this is where we left. We had this copy stamp, and actually what we're gonna do is replace it by a copy to points. So the main difference is just that the copy to points is much more simple, and it's got the advantage of being multi-threaded, so that can be a little faster than using the copy stamp, but we just have to create our own attribute. To do so, I'm dropping a point VOP that I'm gonna call point P scale. Let's move those a bit and let's dive inside the point VOP. So I'm dropping a turbulence noise. So for now we're just gonna create a turbulence to drive the scale, and I'm dropping a fit range to contrast those values. So let's first play with the frequency. Like a frequency of 10 seems to get a pretty interesting result, and we can contrast this with the source min and source max, so they get a little more sharp. And let's export this as a float attribute we're gonna call P scale, which is an internal attribute of Houdini to deal with the scale of any particles and points. So I'm renaming fit range fit turbulence, and let's drop another fit range. This one's gonna control the global output of this attribute, so I'm calling it fit output, and I'm promoting the parameters of the destination min and destination max, that we can access that at the root of the point VOP. So let's edit the parameters and rename that properly. We're gonna reuse those nodes quite a bit, so let's just make those clean. So now we can start seeing some scale appearing, and it's based on the turbulence we created, so that's pretty cool. Now this scale variation is based on a noise. Let's say we'd like some very random variation. How we would do that would be based on the random function, and we would randomize the point number. So it would attribute a random value between 0 and 1 for each point. If we replace that in fit output, that's what we get. And it looks much more random, which can be handy in some situations. So I still want to keep the turbulence just in case, so I'm adding a switch. And in edit parameters, we actually gonna drag and drop the switch index, and we're gonna call it use noise. And let's switch the type to toggle, so that it's, so in here we're gonna promote a bunch of parameters to get control over the noise. Yep, and the fit turbulence as well. And if we edit the parameter, we're gonna create some group to make it clean. So I'm drag and dropping all the noise parameters inside this folder that I'm calling noise, and let's make the folder type to simple. And I'm adding another folder this time that I'm gonna call remap, and it's a simple folder as well. And this would be min input and max input. All right, let's hit apply. So that's great, we got a nice little UI. Now the thing is, with this use noise, I'd like it to lock or unlock the noise folder based on its activation. So inside this noise group, I'm gonna add this expression, which is switcher equals 0. Now if we enable it, it's gonna be unlocked, and if it's unchecked, it's gonna be locked. That's as simple as that. Cool. So we got some nice scale variation, but I think we can still make that better. You see, the problem is we may want to affect the size based on the border. So that's the density attribute we created, and it's fading at the edges. We want the same kind of treatment on this attribute P scale. So I'm just gonna copy the border attribute. First, let's decrease a bit its value and copy paste it. So let's replug it properly. First input goes here, second one just here, and renaming border attribute pscale and border scale as an attribute name. And let's increase the blend width. So this one is like spreading more toward the center. So we're gonna call this attribute inside the point VOP, the pscale point VOP. So let's move that a bit and let's create a multiply. So we're gonna multiply the pscale border attribute we created, border pscale. Right, and let's remap it with a ramp parameter. So I'm gonna switch that to float, spline ramp, and call this one scale fall off. Let's apply the same name for label. Now look at that, we can control its shape through the ramp that we created. Well, doesn't seem to work. I'm failing with my demonstration. So what's going on? Let's plug that into the color. So it looks like it's just a constant, really. Let's plug the attributes. It's all black. Okay, I did a typo. The proper name is border scale. Now it's working properly. All right, so it's a little too crisp. So let's add some more fall off, like so, and maybe we can switch the interpolation to be spline so that it's a little smoother. So now we have a scale that's fading toward the edges of the rock. That's pretty cool. So we could play a bit more with the contrast min max input and play with the output values of the pscale as well, like increasing a bit the max size. Of course, if we want different result, we could just push the offset. Alright, pretty neat. Now if we disable the noise, we have no way to control the different result of the randomness. So we need to create a seed parameter. To do so, let's multiply the point number, and it's going to be multiplied with a parameter, a custom integer that we're going to call seed. And the minimum value is going to be 1, just so that we are sure that his value won't be 0 at some point. And label seed random. That's cool. So now if we try to play with that, we got different result. That's pretty neat. Let's edit the parameters, and I'm gonna create a group for that seed random. Let's copy this little expression into the hide, so that actually we just hide it instead of locking it. And I'm adding another folder for the seed random, like so. Let's call it random, hit apply. So we want to control when it hides or not. So let's just paste that and set the result equal to 1. And now if we press 1, it's actually hiding the noise parameters and showing up the random folder. Sweet. All right, let's create another control. We copy past the point VOP and gonna call that scale Y. So we wanna randomize the scale just in Y so that we bring some extra variations in breakup. So to do that, we don't need the pscale but the scale attribute. This attribute is actually a vector which need 3 floats. So right now our attributes is just 1 float. So we need to convert that into a vector. So I'm gonna plug that into the second input of the float to vector, which correspond to the y-axis. And I'm creating a constant, so I don't want to affect the x and z axis. So it's just going to be 1 as a default values. And as you can see, now it's stretching in y. So let's play with the max output, and you can see that now we can more or less stretch just the length of these crystals. So I'm just resetting the p-scale just so that it's a little a bit more clear. Yeah, now we can see it's just affecting the y-axis and not just all the axis like the p-scale does. Now that's great, but the problem I have with the border attribute we created is that I still want some larger values in the border, just in some places, so that we get some bigger crystal at some point. Like right now there is no chance that we can grow any big crystal. So let's create a turbulence. So I'm plugging the position to the point position, and we're gonna remap those values again. You know the drill. Contrast it a bit, and we're gonna combine that with a maximum function. What it does is that it's combining the maximum values of both input. It's not adding it like a add node would do. It's just gonna combine the maximum values together. So I'm promoting some parameters that could help, like that, and let's replug that here, and the bind export to the color. All right, let's see. All right, then again, I'm gonna clean a bit those guys. Boop, boop, boop. So that's gonna be a simple folder, border breakup, and another folder for the remap. That's the min input, max input, and the max output. Sweet. So we see that if we try to decrease the max output, we just got tiny crystals, while if we increase it, we have more chance of having bigger crystal to the edges. Alright, I'm gonna fine-tune and play a bit more with the parameters for the p-scale that we created. So the dark areas can give us an idea where we're gonna get the smaller crystal, while the white values will give us ideas where the bigger crystals gonna sit. Alright, it's not bad. Some interesting variation, I think. Let's re-enable the scale Y. So the thing is, it's already scaling in Y the ones that are in the edges. So I'm gonna reset that, and actually let's reduce the size of the one in center, just like that. So we'll probably tweak a bit more those parameters once we see the final result with the rotation, the ID variation. So that's good for now. Next lesson will be about rotation variation.